Okay, on three, ready. 1, 2, 3. Toque aqui é bem liso. Cuidado com a cabeça. Uau, ela se mexeu. Okay, on three, ready? Ready. 1, 2, 3, lift. It's heavy. Okay, down slow. Também. Vamos tentar erguer mais. All right, guide the head this way. Okay, pushing the midsection now. Coils are shifting, tails falling, keep it steady. All right, keep it steady. Got it, it's moving. Guide the head this way, almost there. It's moving away, quick! Somebody block the door! Easy there! Not today!
Whoa, it's actually moving!
Look at the scales shift!
Careful, kids, it's huge!
Awesome.
Whoa, it's moving!
Look at that!
Careful, don't get too close!
Whoa, it's moving!
Yeah.
Incredible engineering.
Titanoboa is considered the largest snake that ever lived in Earth's history. Its full scientific name is Titanoboa cerrejonensis. The name comes from the Greek word titan, meaning a giant mythical being, and the Latin word boar, referring to boar snakes. The term cerrejonensis comes from Cerrejón in Colombia, where the first fossils were discovered. The species was officially described in 2009 by scientists including Jonathan Ivan Block, Carlos Alberto Jaramillo, and Jason James Head. By studying the fossils found in Colombia, they identified a previously unknown species of enormous snake. Titanoboa lived approximately 58 million years ago during the Paleocene epoch, shortly after the extinction of the dinosaurs. At that time, Earth's climate was much warmer and more humid than today. The region that is now South America was covered with dense tropical rainforests, swamps, and large river systems. Titanoboa lived in this hot and humid environment. As a cold-blooded animal, its body temperature depended on the surrounding climate, which is why such a massive size was only possible in extremely warm conditions. The fossils of Titanoboa were discovered in the Cerrejón coal mine in Colombia. During the Paleocene, this area was a tropical rainforest. Fossil remains, including vertebrae and ribs, were uncovered during mining operations. Although a complete skeleton has not been found, hundreds of vertebrae allowed scientists to estimate its size. By comparing the vertebrae with those of modern boars, researchers concluded that Titanoboa was about 12-14 meters 40-46 feet long and weighed around 1.2 metric tons. Its body was extremely thick, nearly 1 meter, about 3 feet in diameter at its widest point. This made it nearly twice as long and several times heavier than the largest modern anacondas. Titanoboa likely lived near water and probably spent much of its time in rivers and swamps. It was non-venomous and killed its prey by constriction, similar to modern boars. Its diet likely consisted of large fish and ancient crocodile-like reptiles. Its jaws were adapted to swallow large prey whole. At that time, South America had many large reptiles, providing abundant food sources for such a massive predator. Titanoboa belonged to the boar family Boidae and is considered an ancient relative of modern boar snakes. It did not evolve directly into anacondas or pythons. Evolution works like a branching tree, and Titanoboa was one of those branches. Pythons and boars share a more ancient common ancestor, while Titanoboa represents a giant lineage that eventually became extinct. The snake's enormous size is thought to be closely tied to the climate of the Paleocene. Snakes, similar to other poikilothermic cold-blooded animals, have metabolic rates that are influenced by the temperature of the ambient environment. To maintain normal growth, snakes must have the proper amount of warmth. A snake would need an exceptionally warm environment, such as the one that characterized the Paleocene, to grow as large as Titanoboa. Titanoboa probably spent much of its time in the water. The sedimentary structure of the region's rocks and the preservation of water-loving organisms such as mangrove-like plants, crocodilians, turtles, and fishes as fossils in the strata indicate that the region was waterlogged. Similarly, modern anacondas spend most of their time in or near the water, where they hide amid vegetation in the shallows and ambush prey. It is extremely likely that Titanoboa had similar habits, because the animal's large size would have made living on land awkward or impossible. Titanoboa specimens are either incomplete or undescribed, consisting primarily of thoracic vertebrae that were located before anterior of the cloaker, which possess the same characteristics as other boids and especially boar, such as a short, posteriorly pointing prezygoperphyseal process. However, Titanoboa's vertebrae are distinct due to being very robust and with a uniquely T-shaped newel spine, which also has an expanded posterior margin and a thin, blade-like anterior process. It also has much smaller foraminous small pits in bone on its center and lateral sides, contrary to those of many other boids. The skull material is only briefly described in a 2013 abstract. According to it, Titanoboa has a high amount of palatal and marginal tooth precisions compared to other boids. The quadrate bone is oriented at a low angle, and the articulation joint of both the palatine to pterygoid and pterygoid to quadrate are heavily reduced, a trait absent in its relatives. The teeth themselves are weakly ankylosed. They are not strongly connected to the jawbone. Its extinction was likely caused by several factors. After the Paleocene, global temperatures gradually cooled, tropical habitats shrank, and forests and swamps became less widespread. Because cold-blooded animals rely on environmental heat, maintaining such a gigantic body size became more difficult. Changes in ecosystems and food availability may also have contributed. Titanoboa became completely extinct millions of years ago. There are occasional stories and legends about giant unknown snakes still living in the Amazon rainforest, but scientifically, it is extremely unlikely that Titanoboa survives today. An animal of that size would be very difficult to hide, especially with modern scientific exploration and research. No credible evidence has ever been found to suggest that Titanoboa still exists. Titanoboa is important not only as the largest known snake in history, but also as evidence for understanding ancient Earth climates. Its enormous body size suggests that Paleocene temperatures were significantly higher than today. For this reason, Titanoboa remains one of the most fascinating and significant discoveries in paleontology.